Okay, let's get out our guided practice. We're going to go over these problems. Remember, if you got anything wrong, you should be correcting it. You are welcome to pause the video anytime, erase, make corrections, and then continue with the video. So let's look at number one, 44 points and 4/4. We're supposed to write each rate as a unit rate. So the first thing we want to do here with this problem is we want to first write the rate. So we have 44 points, and that should be in your numerator. And we have 4/4 in the denominator. Now, whenever we are trying to simplify a rate, and remember, you must have your unit with your numbers. If you don't have your units with the number, it is not a rate, it is just a fraction. So we're going to now divide, because 4 is the greatest common factor that can go into 44 and 4. So we're going to divide by 4, and now we end up with 11 points over 1/4. And once you get 1 in your denominator, that tells you that you have simplified your rate, and it is a unit rate because that 1 represents unit. So number 1 is 11 points over 1/4, or you can say 11 points per quarter if you want to use that word. Let's look at number 2. Number 2 says 125 feet to 5 seconds. Once again, you want to write this as a rate, keeping the unit with the number. Now we're going to divide our numerator by 5 and our denominator by 5 because that is the greatest common factor between 125 and 5. When I divide my numerator, I get 25 feet. 5 divided by 5 gives me 1 second. So our unit rate again is 25 feet per second, or 25 feet to 1 second. Number 3. It says 360 miles traveled on 12 gallons of gasoline. So once again, we're going to write 360 miles in our numerator over 12 gallons. We want to make sure what is the greatest common factor between 360 and 12. 12 can go into 360 evenly, and 12 can go into 12 evenly. So we're going to divide our numerator and denominator by 12. When I divide 360 divided by 12, I get 30 miles in my numerator. 12 divided by 12, I get 1 gallon in my denominator. So our unit rate is 30 miles per gallon. Number 4. Number 4, 12 meters over 28 seconds. Now, once again, when we look at this problem, we're going to notice the common denominator here, or if we look here for the greatest common factor, we see that we're not going to get a number that's going to give us a 1. So that means we're going to end up with a fraction somewhere. The only thing we can do right now is we can decide what is the greatest common factor between 12 and 28. That would be 4. So I'm going to divide my numerator by 4 and my denominator by 4. And when I do that, 12 divided by 4 is 3. So I'm going to get 3 meters in my numerator. 28 divided by 4 gives me 7 seconds in my denominator. Now remember what we're trying to do. We're trying to find the unit rate. So So if I look at my answer here, my denominator does not have a 1. It has a 7. So in order for me to get a 1 in my denominator, I must divide by that number. So I have to go one more step now. I must divide my numerator by 7 and my denominator by 7. Once I do that, I'm going to end up with a fraction now in my numerator. So 3 over 7, or 3 divided by 7, that's my meters. Okay, 7 divided by 7 is 1 for my seconds. Now you see I have a 1 in my denominator. This is now a unit rate because I have a 1 in my denominator. Now, we cannot write fractions in this form, a fraction within a fraction. So what we must do is rewrite this so that it makes more sense. So we're simply going to just rewrite it in this form, 37 meters per second. And that's how you want to write your final answer in that form. It makes more sense this way. We cannot have a fraction within a fraction. And the only time you would get this form is when your common denominator, which is the greatest common factor here, will not leave a 1 in your denominator. So you know at this point, your answer should be in a fraction form. Okay, let's go to number 5. Molly shot 20 baskets in 4 minutes. So this is Molly. 20 baskets in 4 minutes. Nico shot 42 baskets in 6 minutes. So I'm going to come over here for Nico and put 42 baskets for 6 minutes. Now, and I'm just going to come up here and label, so I'll have all my information. That's Molly, and this is Nico. Now it says here, how many more baskets did Nico shoot per minute? Keyword per minute. So that means we must first get 1 minute in our denominators. So I know on this side, I can divide my numerator and denominator by 4 for Molly to get a 1 in my denominator. 20 divided by 4 is 5, so I end up with 5 baskets over 1 minute. Let's go to Nico. Again, I want to get a 1 in my denominator, so I'm going to divide by 6 because I know 6 can go into 42 evenly. 42 divided by 6 is 7, so I have 7 baskets over 1 minute. And then we're going to go back to the question. It says here, how many more baskets did Nico shoot per minute? So that is going to be a subtraction problem. That means we have to find the difference. So now Nico is 7, and we're going to subtract 5, and we will see that Nico shot 7 more baskets. I'm sorry, 2 more baskets. So the answer is 2 baskets per minute for Nico. Let's look at number 6. Number 6 says, for Carolina's birthday, her mom took her and 4 friends to a water park. Carolina's mom paid $40 for 5 student tickets. What was the price for 1 student ticket? So once again, we're going to set up our unit. We're going to set up our rate, which is simply $40 to 5 students. Notice you must put your units with each one of your numbers. With money, the dollar sign is considered your unit. Now we want to find out how much for one student. So we're going to look at our denominator. We see we have 5, and I know 5 can go into 40 evenly. So I'm going to divide by 5. When I divide by 5, I get $8 over one student. $8 over one student. So of course, it asks what was the price of one student ticket. The price is $8. Let's look at number 7. Now for number 7, this is just a general question for you to think about the essential questions we've been talking about at the very beginning of the lesson about rates, ratios. How are rates and ratios related? Well, one thing that you can say is, go back to the definition, a rate is a ratio. So that's how they're related. A rate is a ratio. Remember, these are rates. This is a ratio because they are comparing two things. So for number 7, this is what you want to write. A rate is a ratio that compares two quantities. And this is part of your definition. Two quantities with different kinds of units. Different kinds of units. And that shows the relationship between a rate and a ratio. Okay, at this point we're going to stop, and you're going to notice over in the bottom right-hand corner, there's a box that says rate yourself. So we're going to just rate based on what you have learned from the examples, from the practice that you did it yourself, and on the guided practice. I want you to rate yourself on how well you're understanding unit rate. So the top box says, I understand how to find a unit rate. Put a check mark if you feel you do understand how to find a unit rate now. And if you still have some questions about rates, then you put a check mark. And you will need to go online. You'll see the little tutor symbol. When you go online to your ebook, there's a tutor symbol that you can use, and it will go back through some of those questions, do different examples for you to help you get a better understanding. So do that right now. Put a check mark. And once you're done, we're ready to move on to our independent practice. All right, so let's go to number 1 on our independent practice. Now, once again, this is just like your guided practice. You have your examples from your notes that you can refer back to. So on number 1 is 72 ounces in 6 states. We're supposed to find the unit rate. So for number 1, you should have gotten 12 ounces over 1 state. How you find that answer? You simply divide your numerator and your denominator by 6 for number 1. Let's go to number 2. For number 2, you should have gotten 18 water bottles over 1 case. To get that answer, once again, you have 162 to 9. You simply divide your numerator and your denominator by 9, because 9 can go into both your numerator and your denominator. All right, let's go to number 3. Number 3, Marcella divided 40.8 gallons of paint into 8 containers. How much paint is in each container? The word each means 1 as well. You should have gotten 5.1, and this is a whole number divided into a decimal number. We've done those before. So you should have gotten 5.1 gallons to to one container. So you can have a decimal answer within your fraction. And you get that answer simply by dividing your numerator and your denominator by 8. Let's go to number 4. Number 4, Central Subs made 27 sandwiches using 12 pounds of turkey. So they're giving you your sandwiches and they're giving you your pounds of turkey. How much turkey was used per sandwich? So remember, if you can't decide what goes in your numerator or denominator, read the question, look at what they're asking you. How much turkey? So we're going to put our turkey in the numerator, which is 12 pounds, okay? And I'm going to work this one out for you so you can see that. 12 pounds per sandwich, so we're going to put our sandwich in the denominator. So you're going to write it exactly how it is said in your question. Pounds per sandwich. Now, since it says per sandwich, notice we're trying to get a 1 in our denominator, but we see here that we can't get a 1 in our denominator this way. So whenever you see that your denominator number cannot go evenly into our numerator and denominator, that tells us that we're going to have a fraction answer somewhere. So the only thing we can do with this problem is simply reduce it down first to its lowest terms. And if I look here, I know that 3 can go into 12 and 27. So I'm going to divide my numerator by 3 and my denominator by 3. 12 divided by 3 is 4. So I have 4 pounds. 27 divided by 3 is 9. And I have 9 sandwiches. Okay? So, 4 pounds of turkey to 9 sandwiches. But we got to remember what the question asks. It asks us how much turkey for 1 sandwich. So remember, this is where we got to end up dividing by 9 now. So when I divide by 9, I must divide by 9 in my numerator and my denominator because I want to get a 1 in my denominator. So that means my numerator becomes a fraction. 4 divided by 9, so that's 4 ninths pounds of turkey per 1, because 9 divided by 9, sandwich. And that is how you get your final answer on this problem. Notice 1, 2, and 3, they all came out evenly with a 1 in our denominator. But with 4, we were not able to get a 1 in our denominator, so that tells you here that you're going to have to get a fraction answer for your first unit in order to make your second unit have a 1 in the denominator. Okay, let's look at number 5. The results of a car race are shown. Determine who drove the fastest and explain. Now, when you look over here, you have 3 people here. So I'm going to set this up for you. We're first going to look at Cutright. He's the driver. And we are trying to find out how fast he's going. Now, we know that he can go 35 laps in 84 minutes. So, 35 laps in 84 minutes. All right, we know that much for Cutright. Let's go to Evans. Evans can go 42 laps in 96.6 minutes. And then we have Loza. And Loza can go 38 laps in 102.6 minutes. Now, one thing that we know is we can do long division to divide to figure out how much for 1. So I can come over here and do long division because I'm trying to compare. So I really want to find out, I can divide 35 into 84 and see how much for 1 lap, how fast it can go in 1 lap. If I can figure that out for all 3 of them, then that can determine who's the fastest. So if I take 35 into 84, one thing we got to remember, always look at your first number, your tens value, 3 and 8. That will help you. So I know 3 can go into 8 2 times. And I know if I multiply by 3, that's going to give me over. So I'm going to do 2. And remember, I'm not trying to put 35 into 8. I'm putting 35 into 84. So we're going to put our 2 right above the 4. And we're going to multiply as usual here and subtract. When I subtract, I get 14. Now remember, since we're trying to find out time, we cannot have any remainders. So we don't write it with a remainder. But we must keep going until we get a 0 remainder. So we're going to have to add a decimal point at the end. And whenever you add a decimal point, you must bring it directly up into your answer. And in order to continue, we must now add on a 0 in our problem. And I'm going to bring that down. Now I have 35 into 140. Once again, I'm going to look at my 3 here, but I'm going to compare it with my 14 now. And I know 3 times 4 gives me 12, so that's going to help me out. 3 times 4 gives me 12, so I'm going to try that with 35 and 4. So I'm going to put my 4 here. And when I multiply here, 4 times 5 gives me 20. I bring down my 0, carry my 2. 4 times 3 is 12, plus 2 gives me my 14, and I see it comes out evenly. And I can erase that 2 there. Now I have my remainder of 0. And so that's what you would do for each one of these. I'm going to set them up. Notice when you set them up, notice 42 into 96.6. This one already has a decimal point in it, so it comes directly up, and you would work this problem, work that one out all the way. The same for 38 into 102.6. You set it up and do your long division. Their decimal point comes directly up, and you use your long division. Now, after you have done all 3 of these, you should see that Evan's going to get 2.3. Okay? He should end up giving 2.3 here. And if you come here and let's do, I know here 3 times 3 is 9. Okay? So I'm going to come here and say, well, let's try 3 here. Let's just try and see what happens. 3 times 4 is 24. So when I put a 4 here and bring this 2 here, 9, 10, 11, that's too much, okay? And so that's what you're going to look at. You use that to help you. Test it if it's too much. That tells you, oh, I got to go down 1, okay? So now I'm going to go down to 2. 8 times 2 is 16. Carry your 1. That becomes a 7. Now we're going to subtract. 12 here. Remember, this becomes a 12 now because we borrowed 1 over here to make that a 9. That became a 0. So we know 6 and a 2, bring down a 6. Now once again, I can look at 3 with 26 and I think about 3 and 8, that gives me 24. So that's going to help me out. So I'm going to try 8. Now does that mean it's going to work? No. So let's try it out. 8 times 8 is 64. So when I put my 4 in there at 6, I know that's too big. So that tells me, let's go down. Let's try 7. 8 times 7 is 56. Carry my 5. 7 times 3 is 21 plus 5 is 26, and it checks out. And I get 0. So I now see that these are all the times for 1 lap. And remember, with time, you look at the smallest value because that is the fastest person. So in this case, Evans would be the fastest because he was able to travel 2.3 minutes per lap. Okay, let's get number 6. Theo's mom bought an 8-pack of juice boxes at the store for $4. So, the first thing we know, okay, we know there were 8, and I'm just going to write boxes here. 8 boxes for $4. 8 boxes for $4. Now, what we're trying to find out is the unit rate again. So the unit rate means how many for one box. So if I divide by 4, because I'm trying to find out how much for $1 here, this is only going to tell me this information. Okay? So if I look at that and just say, I'm just going to divide by 4 because I'm going to get the 1 in my denominator, yes, that is a unit rate, but that's only telling us that we're going to be paying $1 for 2 boxes. So this one is a little tricky because they want you to find out the unit rate for 1 juice box. And if you look at this, we know if 2 boxes is $1, that means 1 box would be 50 cents. Because you're just simply taking half of that. And you can write as 50 cents per box or 50 cents over 1 box. But that would be your unit rate. Let's look at number 7. Joshua's cousin pledged $12 for a charity walk. If Joshua walked 3 miles, how much did his cousin pay per mile? Keyword per, that means 1. So for number 7, this is how you should set it up. Again, $12 in your numerator and 3 miles in your denominator. Once again, since they're asking me this time how much per mile, this is going to help me out. So I can divide my numerator and denominator by 3. And when I do this, 12 divided by 3 would give me $4 in my numerator. 3 divided by 3 would give me 1 mile. So that means that he paid $4 per mile. Okay, let's look at number 8. Now, number 8 has a lot of parts to it, and you got to think about it. What's happening here? It says the Loving Lemon Company. And I'm just going to shorten this up. The Loving Lemon Company. I'm going to shorten it up. Says 4-gallon jugs. So remember when we have word problems, we always just kind of jot down the things they give us. You can even underline it or highlight all the things that are given to you. And they sell these for $24. Okay, 4-gallon jugs for $24. And then we have the Sweet and Sour Company. So I'm going to come over here and do S, Sweet and Sour Company. Now, the Sweet and Sour Company sells an 8-pack of 1-quart bottles. So that's the same thing as saying 8-quart bottles, okay? There are 8 of them in that pack. So that's 8 quarts. And they're selling theirs for $16. Okay? Now, what we're supposed to do with this problem is find out which company has a higher unit price. Which one is higher? Now, before we can even begin this problem, we're supposed to notice that, well, first of all, they're talking about 2 different things, and we cannot compare when they're talking about 2 different things. This one has 4-gallon jugs, and this one has 8 quarts. So, what we have to remember is we got to be able to find out what can we compare here. Well, we know, or we should know, that there are 4 quarts in 1 gallon. So if there are 4 quarts in 1 gallon, I know now that I can change this by multiplying by 4, and this really becomes 16 quarts. So now I have 16 quarts at $24 compared to 8 quarts at $6. I'm sorry, at $16. And now I can now compare these two because they have the same units now. Your units must always be the same in order to compare. Now when we look at 16 and 24, we want to think about what has the greatest common factor. And in this case, it's going to be 8. So I'm going to divide by 8 in my numerator and 8 in my denominator. 16 divided by 8 will be 2 quarts. 24 divided by 8 would be $3. Now that's still not telling me anything about the unit price because it says $3. Now I do know if 2 quarts is $3, then 1 quart would be half of $3, which is $1.50. So you simply take half of 2 and half of 3. And remember, this is not the number 3, it is the dollar, $3. Now we're going to come over here to the Sweet and Sour Company and do the same thing. Again, the greatest common factor will be 8, so I can divide 8 in my numerator and 8 in my denominator. 8 divided by 8 is 1, so I get 1 quart here. 16 divided by 8 gives me $2. So the Sweet and Sour Company is selling 1 quart for $2, and the Loving Lemon Company is selling 1 quart for $1.50. So the question is asking which company has a higher unit price. It's going to be the Sweet and Sour Company because they're selling theirs for $2. Okay, let's look at number 9. It says the Shanghai Maglev train is one of the fastest trains in the world, traveling about 2,144 miles in 8 hours. Okay, so this is number 9. Now part A says, how many miles does it travel in 1 hour? You simply divide. Divide by 8, divide by 8. When you divide by 8, you're going to get 268 miles in 1 hour. So that would be your answer for part A. Now, let's look at what it says for part B. The distance between Columbus, Ohio, and New York City is about 560 miles. How many hours would it take the train to travel between those two cities? So, we're going to use our answer from part A to help us with part B. Now, we know it takes 1 hour to travel 268 miles. And we're trying to get to 560. So basically, we're going to divide 268 into 560. Okay? We're going to do some dividing. Now, once again, I can look at my 2 with my 5 here. And I'm going to go to 2 because I know 3 is going to be too much. So I'm going to test out 2 and see if that works. 8 times 2 is 16. Carry the 1. 6 times 2 is 12 plus 1 is 13. Carry the 1. 2 times 2 is 4 plus 1 is 5. So when I get this answer here and I can do my long division, subtracting, this becomes 10, that becomes 5. We get 4, 2. Now remember, we're just answering here so I can bring down my 0 and I can continue doing this over and over again. I know it's not going to go into this anymore. So that's going to tell me here that when I go and actually work our problem out, I'm really looking at my whole number answer that I get, okay? Because they're just asking me how long will it take me. So on this problem, we're going to say about 2 hours. Because we do have a remainder here, but we cannot use that remainder, okay? So we're going to say about 2 hours. We're not going to write it as a remainder, So that's going to be our answer for the second part, about 2 hours. All right, let's get number 10. Number 10 has some big numbers that we're going to work with. We're trying to compare these 5 states here using their population estimate with their area. So we're trying to find the population density, and in order to find the population density, we must divide. So what we're going to do here, we will be dividing the area for each of these states. So we have California, we're going to be dividing. Now, what we're going to do on this, which I'm going to give you a break on, instead of doing long division for this long number, I'm going to let you use your calculators on this. Okay? Now, notice how I set this up on paper. If I was doing long division, I am doing 36,500,000 divided by 163,707. So that means I must put it into the calculator that way. So you can use your calculator that you have on your computer. Just type in calculator in Spotlight if you don't know how to get there. And in your calculator, you would actually okay? So this is how you would use your calculator. So I'm going to put this here. Now we're only doing this because these are some very big numbers and we will be here all day. Not really. So you're going to set this up for each one of your states. So for California, we're going to use our calculator. And it says in our answer here to round it to the nearest 10th. So I'm going to go ahead and set up for each one. Florida, Iowa, New Jersey, and Wyoming. Now, when you use your calculator for California, you should get 223.0. It says to round to the nearest 10, so they're just showing you that there's a 0 in the 10th place for California. For Florida, you should get 278.3 people per square mile. So let's go ahead and write the whole unit rate out. People per square mile. And notice how I'm using the little slash. That slash stands for per, so you can do that as well. All right, let's go to Iowa. For Iowa, we're going to do the same thing, and we're going to get 53.1 people per square mile. New Jersey is 996.3 people per square mile. And once again, you don't have to do all the long division since these are bigger numbers. I'm going to allow you to use your calculators on these. And then, of course, for Wyoming, you should get 5.3 people per square mile. So for part A, you had to actually find the population density by dividing the area with the population. So these are your answers you should have gotten for each one of those. Once again, use your calculator so that you can see. If you're not sure, use the calculator on these so you can see if you are getting these numbers right. That will also determine how well you know how to use the calculator. All right, let's go to part B. Now, there was a graph over to the side. If you go to the graph over to the side, for California, notice California, there was a 200, and notice California has 223. So you should have your bar graph a little bit over that 200. And remember it says bar graph, so you must make bars. Okay, so that was for California. Let's go to Florida. Florida was, notice this was 400, and we know Florida does not go over 400, but it is a little bit higher than California. So you're going to make it a little bit higher than California. I'm going to make Florida a little, make California Florida should be a little bit over, but it can't go over the 400. And it can't go over that 300 mark as well. So let's go to Iowa. Now, Iowa was just 53. So notice this little mark here is like 100. So you know 53 is going to be a little small one there. I want to go over 300. And then let's look at New Jersey. There's New Jersey. New Jersey was 996. Now, that means you got to come all the way up here. There's 200, 400. That would be 600. That would be 800. So this would be 1,000. And we know in between that is 900. So I know for New Jersey, we got to have a bar that's going over 900, but you can't touch. It should be very close to your 1,000. So that's New Jersey. And then Wyoming is, very small, 5.3. So it's going to be just a little bit. But that's how your bar graph should look for number 10. Now, part C was just asking to justify without calculating. How could you look at what you have here to calculate Connecticut? If Connecticut has an area of 4,875. Well, what you could do is you're looking at Connecticut and you're going to be comparing it with Iowa. If we look at Iowa here, Iowa has 53.1 people per square mile. And it says here that Connecticut has about the same population as Iowa. So if we look at Iowa and the population is 2,990,000, and we look at the people per square mile here for Iowa, then we know if the area is 4,875 for Connecticut, that we know it's going to be a slightly higher population density, okay? So this is the population density for Iowa, and that's going to give us a higher R for it. Okay, so in 10C it says, Connecticut has about the same population as Iowa, but its area is 4,875 square miles. Without calculating, compare Connecticut's population density to Iowa's, and we must justify the answer. So over here, I've listed down the information that we knew from Iowa, and it says that Connecticut has about the same population. So notice here, Iowa has 2,990,000 people. And we're saying that Connecticut has the same amount or approximately the same amount. So we have a large amount of people here, but look at the area for Connecticut. It is smaller than the area for Iowa. So we're going to use that information, and we can tell here, based on what we know with Iowa, we know the population density for Iowa was 53.1 person per square mile. So if we're trying to fit all of these people into this smaller area than we had for Iowa, then we know that our population density would be much bigger because we have a large amount of people trying to go into a smaller area. And so over here, I summed it up using this. If you've written yours a different way, but it is similar to what I have here, then you're fine. But basically what we're saying is Connecticut has a higher population density because the same number of people here for Iowa are being distributed into a smaller area. So that's going to give you a higher population density if you were to divide it out. Okay, for number 11, you have to find the error that was made in the problem here. And it says that Julie wrote the rate $108 in 6 weeks. So she was trying to find the unit rate, and she wrote it as $54 in 3 weeks. What was her mistake? Well, first of all, when we're trying to find the unit rate, we must have a 1 in our denominator, and she has a 3. So she did not, number one, divide it all the way out to get a 1. Now, the other thing she could have done was divide by 6 because that's the greatest common factor. Instead, she divided by 2. And so that also left her with a 3 in the denominator. So if we divided this by 6, and divide by 6 in our denominator, you really should get $18 over 1 week. So her mistake was that she did not divide by 6. She does not have a 1 in her denominator. She has a 3. Number 12. It says the ratio of red jelly beans to yellow jelly beans in a dish is 3 to 4. If Greg eats 3 red jelly beans and 6 yellow ones, so we're going to red and yellow. And we have Greg's going to eat 3 red and 6 yellow. So you're setting up a table. The ratio is 4 to 5. So we know this is our ratio here. So when we're doing ratio, it's like we are multiplying. So that means here, if the ratio of red is 4 to 5, we know 3 times 4 give us 12. And 5 times 6 will give us 30 here. So just looking at this part for Greg, red 3, yellow 6. If we were using this ratio of 4 to 5, that means he would actually have eaten 12 red and 30 yellow. That would be 12 and 30. So the question that's being asked is, how many yellow jelly beans were originally in the dish? Now, we just found the ratio here. We know here 12 to 30. That is the ratio of 4 to 5. But since we are looking total yellow, okay, we now know that total in the dish should be the 30 plus the 6 because we're asking for the original. So the 4 to 5 ratio left us with 30, and he had already eaten 6 of them. So they're asking us for the original, so we're going to go back and add to 6 that were eaten by him so that we can see he had a total of 36 to begin with. So your answer for number 12 should be 36 yellow jelly beans. Okay, number 13. We're going to look at number 13. Number 13 is asking us to justify the conclusion again. So if we look at number 13, it says here that if you travel at a rate of 45 miles, and I'm going to go ahead and write the rate up here, 45 miles in 1 hour, and it says per hour, but I'm going to write it as a rate as 1 hour. How many minutes will it take you to travel 1 mile? Now, notice what we said. We have 1 hour here, but they're asking us about minutes. So what we're going to have to do is convert once again. So I'm going to rewrite my rate. Since they're asking me for minutes, I must convert my 1 hour. And I know there are 60 minutes in 1 hour. So now I have it converted. And what I'm going to do now is I'm going to reduce this down by using the greatest common factor here. I can divide this by 15 in my numerator and 15 in my denominator because I see that's our greatest common factor. And when I get 45 divided by 15, I get 3 miles. 60 minutes divided by 15, I get 4 minutes. Now notice what they're asking us here. They're asking us, look at the question, very important. It says, how many minutes will it take you to travel 1 mile? So I'm trying to find 1 mile, not 3. So anytime you're asked to find 1, that means you can divide by that number. I know 3 divided by 3 would give me that 1 I'm looking for. And whatever I do in my numerator, I must do it in my denominator, and vice versa. So let's look at my new answer here. Now I have 1 mile to 4/3 minutes. And remember what we said about writing a fraction within a fraction. This is really going to be changed to 1 1/3. When we're dealing with time, we normally write it as a mixed number form, or we can say 1 hour and 20 seconds if you really want to be precise. Okay, you can be precise and break it down because 1/3 of 60 is 20 seconds. So we must write this in a form that's more understandable. So we're going to get 1 1/3 minutes per mile. Okay? How we found this, you have to basically go back to the question. Okay? If they were asking us how much for 1 minute, then we would be dividing by 4. But they asked us how much for 1 mile, so we have to go to where the miles is. Now, even if you wrote yours and put your minutes in the numerator and your miles in the denominator, it would not matter because you will have it flipped and you will still be able to see that your minutes will be in the numerator, but it will still be 4/3 minutes. So your final answer is 1 1/3 minutes per mile.